Hi, in this video, you will learn to interpret chemical equations. Then you'll determine the answer to the question, are particles, moles, or mass conserved? The learning targets include, I can identify the type of representative particle in an element or compound. I can interpret a balanced chemical equation in terms of representative particles. This means I can calculate also the total number of particles present from the number of moles. I can interpret a balanced equation in terms of moles. I can interpret a balanced chemical equation in terms of mass. This means I can calculate the molar mass of a compound. I can calculate the mass of a substance using the moles present and the molar mass. Lastly, I can evaluate the evidence to determine if the law of conservation of matter is obeyed for particles, moles, or mass. First, what is a representative particle? A representative particle is the smallest part of the substance that has the same properties of that substance. For example, iron is an element. You know it's made of atoms. Atom is the representative particle, even though atoms are made of protons, electrons, and neutrons. But it is the atom of iron that has the same properties of iron. It is a solid, it is malleable, but the proton, electron, and neutron don't have those properties. Carbon dioxide is a molecular compound made of molecules. Molecules is the representative particle. Every molecule of CO2 is the same as every other molecule of CO2. The molecule of CO2 is made of atoms, which are carbon and oxygen. Carbon exists in forms of graphite and diamond. The properties of diamond and graphite are nowhere near those of carbon dioxide, the gas we exhale. We certainly aren't exhaling diamonds. Wish I was. Lastly, calcium chloride is an ionic compound. Its representative particle is formula units. Formula units are the repeating pattern of one Ca and two Cls that repeats through the whole solid crystal. The formula unit is made further of ions that are made of calcium ions and chloride ions. Those ions do not have the same properties as the ionic compound of calcium chloride, which is why the formula unit is the representative particle. So now we interpret the balanced equation in terms of particles. We read the coefficients in front of each reactant and product and say what type of representative particle it is made of. So one atom of magnesium plus two molecules of HCl form one formula unit of magnesium chloride plus one molecule of H2. Atoms make up magnesium because magnesium is an element. Molecules make up HCl because HCl is a molecular compound. Formula units make up magnesium chloride since magnesium chloride is an ionic compound. Molecules make up H2 since even though H is an element, it is made of a diatomic molecule. Two atoms of H combine to form H2. To interpret the equation in terms of moles, again, we use the coefficients and just replace the particle name with the word mole. So 1 mole of magnesium plus 2 moles of HCl forms 1 mole of magnesium chloride plus 1 mole of H2, hydrogen. Okay, so in chemistry, we can't see one atom, two molecules, or one formula unit, or even one molecule. But what can we see? We can see 1 mole of each of these. So in order to count how many particles are present in 1, 2, or 3 moles, we multiply them all times 6.02 times 10 to the 23rd. So we see we have 6.02 times 10 to the 23rd atoms of Mg, 12.04 times 10 to the 23rd formula units of aluminum chloride. We abbreviated formula units to be FMU. And we have 6.02 times 10 to the 23rd formula units of magnesium chloride and 6.02 times 10 to the 23rd molecules of hydrogen. Notice it was simplified to write 12.04 times 10 to the 23rd formula units as 1.204 times 10 to the 24th. This is done because this is proper scientific notation. On that last slide, you could also see in the speaker notes how those numbers are converted without using a calculator and just by moving the decimal. Now we are going to see if the particles, moles, and total particles are conserved. If we add them up, we see that one atom plus two molecules gives three total particles in the reactants, and that there are two total particles in the products. One formula unit plus one molecule gives you two. Therefore, total particles are not conserved. How about moles? Moles. 1 mole of magnesium plus 2 moles of HCl give 3 moles in the reactants. And then there's 2 moles in the products from 1 mole of magnesium chloride and 1 mole of H2. Well, 3 going to 2 shows you that moles are not conserved. But what about total particles? On the bottom of the screen, you could see that the total particles do not equal the total particles in the product. That is, the total particles in the reactants are not the same as those in the product. So total particles is not conserved. Well, what happens when we interpret the equation in terms of mass? Well, we take the moles present of each reactant and product, and we multiply them by the molar mass. The proper conversion is seen in a separate video. So if we multiply each mole of reactant and product times its molar mass, we see we get 24 for magnesium, 72 for hydrogen HCl, 94 for MgCl2, and 2 for hydrogen. When we total up the masses for the reactants and for the products, we see we get 96. So the mass of the reactants equals the total mass of the products, and therefore mass is conserved and the law of conservation of mass has been demonstrated. Thank you for watching, and I hope this helps you to complete your work.